Hello everyone. In this video, I'm presenting a map-based application I built using Python with Flask for the back-end and JavaScript with Leaflet.js for the front-end. This application is designed to visualize real-time traffic data in Calgary. I'll walk you through how it connects to a PostgreSQL database to retrieve traffic data, such as traffic incidents, cameras, and signals, and how it displays each dataset interactively on the map. Throughout the presentation, I'll explain both the back-end code, which processes the data, and the front-end code, which handles map rendering, icons, and pop-ups. At the end, I'll also demonstrate how each layer functions, showing how we can view data on traffic incidents, camera feeds, and traffic signals right on the map. Base query modifications. In the back-end Python code, we start by setting up a connection to a PostgreSQL database that contains three main tables: traffic incidents, traffic signals, and traffic cameras. Each table stores geographic data along with relevant details for each real-time traffic dataset. To retrieve data from these tables, I've written custom SQL queries. For traffic incidents, for instance, I retrieve the ID, incident location, description, date, and time. For traffic cameras, I fetch data, including the camera location and a URL to a live camera feed. And for traffic signals, we're pulling data about the unit ID, intersection roads, and type of signal. Each query pulls the data in a structured way, which is then formatted as GeoJSON, a format perfect for mapping applications. After executing each query, I structure the results in a GeoJSON format and send them to the front end via a single JSON response when we access the /map data route. Data processing for GeoJSON. Once we retrieve the data from the database, the next step is to process it into the GeoJSON format. GeoJSON is ideal for representing geographic data and works seamlessly with map applications like Leaflet on the front end. In the map data function, each table's data is processed separately. After executing each SQL query, I convert each row of data into a GeoJSON feature. Each feature has a geometry section that includes coordinates and a properties section holding specific attributes like location and description for traffic incidents, or camera location and camera URL for traffic cameras. Each layer is organized by table names, traffic incidents, traffic signals, and traffic cameras in a single GeoJSON structure. This structure is then sent to the front end as JSON when the /map data route is accessed. In the HTML file, I include the Leaflet and marker cluster libraries, which enable map rendering and marker clustering. The map is initialized in JavaScript with Calgary's coordinates, and I add an OpenStreetMap tile layer for a clear, interactive base map. We then use fetch to retrieve the GeoJSON data from the backend. After loading, the data is processed by creating individual layers for each dataset: traffic incidents, traffic cameras, and traffic signals. Each layer is stored in the Layers object and displayed on the map using ELL. Each layer's pop-ups and icons are customized based on its type. For instance, traffic cameras display a location and live camera image. Traffic incidents include location, date, time, and description, while traffic signals display unit ID, roads, and signal type. Pop-up customization plays a big role in how each data point provides detailed information. Using onEach feature in JavaScript, I customized pop-ups for each layer. For traffic incidents, the pop-up shows details such as the location, date, time, and description, with date and time formatted for better readability. In traffic cameras, the pop-up includes the camera location, camera number, and a live camera feed displayed as an embedded image. The camera number and URL are extracted separately to allow for this enhanced display. Finally, for traffic signals, the pop-up provides the unit ID, roads where the signal is located, and type. Each layer has a distinct structure to display information relevant to that type of data. Camera number extraction. Let's focus on how I extract the camera number and URL from the traffic cameras layer. Each entry in the data includes both the camera name and URL in a single field, like camera75, htrafficcam.calgary.ca c74.jpg. Using JavaScript, I applied a regular expression to capture the camera number and URL separately. This allows us to display the camera number as text and the URL as an embedded image. This setup provides a clean, clear view of real-time camera data. Layer control with custom icons. In the map interface, I use custom icons for each layer type to visually distinguish between them. I created a dictionary called Layer Icons to assign an icon for each data layer. A car for traffic incidents, a camera for traffic cameras, and a traffic light for traffic signals. In JavaScript, I link these icons to each data layer, so when displayed, users can easily tell what each icon represents. In the layer control, these icons also appear next to each checkbox. Users can toggle each layer on or off, controlling what data they want to see. To wrap up, we've covered how the application integrates back-end and front-end components to create an interactive map interface. Starting with enhanced database queries, I customized the data format, pop-up content, and icon display. Each layer on the map provides essential information, with features like live camera feeds making it more practical for users. Now let's go through a live demonstration. I'll activate each layer one by one and show how each icon and pop-up work. Here I'm turning on the traffic incidents layer, where each icon represents a traffic incident. When I click on an icon, we see details such as location, date, time, and description. Next, I'll turn on the traffic cameras layer. Each icon represents a traffic camera, and when clicked, the pop-up displays a live feed preview window, showing real-time traffic conditions. Finally, I'll activate the traffic signals layer, where each icon represents a traffic signal. Clicking on an icon provides information like unit ID, roads, and signal type. These features make the application a powerful tool for accessing detailed information for each map layer. Thank you for watching, and I hope this walkthrough has given you a clear understanding of the functionality and customizations involved in the project.